Welcome to Astronomy Daily. I'm thrilled to be bringing you today's fascinating roundup of space and astronomy news. We've got an absolutely packed show ahead, with stories that span from ambitious new European space ventures to spectacular celestial events and groundbreaking scientific discoveries. Today, we'll explore how Europe's aerospace giants are teaming up to challenge Starlink, witness a remarkable asteroid spectacle that lit up Russian skies, and learn about an innovative mission to create artificial eclipses in space. We'll also delve into new research about the origins of Earth's oceans, discover how AI could help future Mars astronauts, and marvel at Hubble's decades-long study of a beautiful distant galaxy. These stories showcase just how dynamic and exciting the field of space exploration continues to be, so let's dive right in. In what could be a major shakeup for the satellite communications industry, Europe's leading aerospace companies are joining forces to take on Elon Musk's Starlink. Under the codename Project Bromo, named after an Indonesian volcano, aerospace giants Airbus, Thales, and Leonardo are exploring plans to establish a new standalone European satellite venture. This ambitious initiative aims to create a European satellite champion modeled after the successful missile maker MBDA, which is jointly owned by several European defense companies. The proposed structure would combine the satellite assets of these major players rather than having one partner acquire assets from the others. The timing of this venture is particularly significant, as Europe's traditional satellite makers have been struggling to adapt to the rapid changes in the industry. While they've historically focused on complex spacecraft in geostationary orbit, the market has been disrupted by the arrival of cheaper, smaller satellites in low Earth orbit, a domain where Starlink has established a commanding presence. The project comes amid broader restructuring efforts in Europe's space sector. Airbus has already announced plans to cut up to 2,500 jobs in its defense and space division, while Thales is in discussions about reducing 1,300 space-related positions. However, industry sources emphasize that Project Bromo is separate from these immediate cost-cutting measures and represents a long-term strategic initiative. While still in its early stages, these talks represent the most serious attempt yet to consolidate Europe's satellite industry after decades of fragmentation. If successful, this new venture could finally give Europe the scale and capabilities needed to compete effectively in the rapidly evolving global satellite market. A spectacular celestial show lit up the skies over Russia's remote Yakutia region early Wednesday morning, as an asteroid made its dramatic entrance into Earth's atmosphere. What makes this event particularly remarkable is that astronomers spotted and tracked this cosmic visitor a full 12 hours before its arrival, a testament to how far our asteroid detection capabilities have come. The European Space Agency confirmed that the asteroid measured about 70 centimeters across, roughly the size of a small car tire. While that might not sound particularly large, it was enough to create an impressive fireball that caught the attention of residents in the Olekminsk and Lensk districts, who reported seeing what looked like a comet's tail streaking across the night sky, followed by a brilliant flash. What's particularly impressive about this event is the precision with which scientists predicted its arrival. Thanks to observations from astronomers worldwide, the alert system was able to predict the impact time within just 10 seconds of accuracy. The asteroid entered Earth's atmosphere at precisely 1:15 a.m. local time, exactly when scientists had calculated it would. This kind of accurate prediction and tracking represents a significant achievement in our planetary defense capabilities. While this particular asteroid was too small to pose any threat, burning up harmlessly in the atmosphere as expected, the incident demonstrates how effectively we can now monitor and track incoming space objects. The Emergencies Ministry in Yakutia confirmed that no damage was reported, though they had placed all official bodies on alert as a precautionary measure. This event serves as a perfect real-world test of our early warning systems and international cooperation in tracking near-Earth objects. The ability to spot even relatively small asteroids hours before impact, track their trajectory with precision, and accurately predict their arrival time shows just how far we've come in protecting our planet from potential cosmic threats. Next up, the European Space Agency is embarking on an extraordinary new mission that will create artificial solar eclipses in space. The Proba 3 mission, set to launch from India's Satish Dhawan Space Center, represents a groundbreaking achievement in precision spacecraft control and solar observation. At the heart of this $210 million mission are two satellites that will perform an intricate orbital dance. These spacecraft will maintain an incredibly precise formation, positioning themselves just 150 meters apart with accuracy down to a few millimeters. Think about that level of precision. It's like perfectly parallel parking two cars in New York and Los Angeles without being off by more than the thickness of a credit card. What makes this mission truly revolutionary is how these satellites will work together. One spacecraft, known as the occulter, will position itself to block out the sun's bright disk, while the second satellite, the coronagraph, will study the sun's mysterious outer atmosphere, or corona. This setup will effectively create an artificial solar eclipse that can last for 6 hours during each orbit, something that's impossible to achieve from Earth, where natural eclipses only last a few minutes. The mission will help solve some of our biggest solar mysteries, including why the corona is mysteriously hundreds of times hotter than the sun's surface, and how the solar wind achieves such incredible speeds. But perhaps even more importantly, this mission will prove out formation flying technologies that could revolutionize future space missions. This demonstration opens up exciting possibilities for future space missions. Imagine large-scale orbital observatories or satellite servicing missions built from multiple spacecraft working in perfect harmony. The Proba 3 mission isn't just about studying the sun. It's about pushing the boundaries of what's possible in space exploration and paving the way for the next generation of space technology. A fascinating new study has reopened the age-old question about where Earth's water came from, and the answer might be written in the stars, or more specifically, in comets. Scientists have discovered that water found on Comet 67P shares remarkable similarities with the water in Earth's oceans, challenging our previous understanding of how our planet became the blue marble we know today. While we've long known that Earth wasn't always the water-rich world it is now, the exact source of our oceans has remained a mystery. Much of the water present during Earth's formation would have vaporized due to our proximity to the sun's intense heat. This led scientists to look elsewhere for the source of our life-giving oceans. The key to this discovery lies in something called the deuterium to hydrogen ratio, essentially a molecular fingerprint that helps scientists trace water's origin across the solar system. Deuterium, a heavier version of hydrogen, is more commonly found in objects that formed farther from the sun, like comets. By comparing these ratios in different celestial bodies, scientists can piece together the cosmic history of water. What makes this new research particularly intriguing is how it addresses previous contradictions in our understanding. Earlier measurements of Comet 67P seem to rule out Jupiter family comets as potential water sources for Earth, showing deuterium levels 3 times higher than our oceans. However, this new study reveals that these measurements might have been skewed by the presence of dust in the comet's atmosphere. The research team found that when water ice attaches to dust particles in a comet's coma, the fuzzy atmosphere surrounding its nucleus, it can create misleading readings. When they accounted for this dust effect and measured the water farther from the comet's surface, they found a much closer match to Earth's oceanic water signature. This discovery suggests that comets like 67P could indeed have played a significant role in delivering water to our early planet during the solar system's tumultuous youth. This revelation not only helps us better understand our own planet's history, but also has important implications for how we study comets and interpret their data in our ongoing quest to understand the origins of our cosmic neighborhood. Now, here's a wild idea, but one that makes sense. Space exploration is about to get a major upgrade with artificial intelligence stepping in as the ultimate cosmic co-pilot. Researchers at the German Aerospace Center are developing sophisticated AI assistants specifically designed to support astronauts on long-duration missions, particularly to Mars, where communication delays with Earth can stretch up to 24 minutes each way. These AI systems, built upon the Mars Exploration Telemetry-Driven Information System, or METIS, are being enhanced to help astronauts make critical decisions without waiting for instructions from mission control. Think of it as having a knowledgeable companion who can instantly access and interpret vast amounts of mission data, procedures, and sensor readings in real time. What makes this system particularly innovative is its combination of different technologies. It uses knowledge graphs to organize and connect complex mission information, augmented reality to display crucial data right in front of astronauts' eyes, and natural language processing to enable simple voice interactions. The system can even verify its own responses against stored mission data, ensuring reliability in critical situations. This isn't just about convenience, it's about survival. When you're millions of miles from Earth, waiting 48 minutes for a round-trip communication about an emergency situation simply isn't an option. The AI assistant can help astronauts troubleshoot problems, manage complex procedures, and make informed decisions independently. Current testing of these systems is already underway, with researchers collaborating with the MIT Media Lab's Space Exploration Initiative. Plans are in place to work with astronauts at the European Astronaut Center next year, moving us closer to a future where AI becomes an indispensable crew member on humanity's journey to the stars. The development builds upon existing AI systems already proving their worth on the International Space Station, where robotic assistants named Honey, Queen, and Bumble help astronauts with daily tasks. These early applications are paving the way for more sophisticated AI support systems that will be crucial for the challenges of deep space exploration. Let me share with you one of the most remarkable examples of scientific patience and dedication in astronomy. The Hubble Space Telescope has been observing a fascinating galaxy called UGC 10043, capturing its evolution through images taken an incredible 23 years apart. Located 150 million light-years from Earth, this spiral galaxy appears to us as a striking thin line across the cosmos when viewed from our perspective. What makes these observations particularly special is how they combine data from both the year 2000 and 2023, giving us an unprecedented look at the galaxy's structure and development over time. When you look at the combined image, you'll notice a distinctive glowing bulge at the galaxy's heart, an egg-shaped structure that extends above and below its flat disk. This bulge is unusually large for a spiral galaxy, and astronomers believe it might be the result of gravitational interactions with nearby dwarf galaxies. It's like watching a cosmic tug-of-war playing out across millions of light-years, where these gravitational forces have actually warped the galaxy's disk, bending it at both ends. The galaxy's arms shine with a bluish light, indicating areas where new stars are actively forming. However, much of this stellar nursery is partially hidden behind thick clouds of cosmic dust, adding to the mystery and complexity of this distant system. These long-term observations by Hubble demonstrate why the telescope has been such a revolutionary tool for astronomy. By revisiting the same cosmic objects over decades, we can track their evolution and piece together the intricate processes that shape our universe. It's like having a time-lapse camera pointed at the cosmos, helping us understand how galaxies live and change over astronomical timescales. And that wraps up today's episode of Astronomy Daily. Thanks so much for joining me. I'm Anna, and it's been a pleasure sharing these fascinating stories from space with you. If you're hungry for more space news, head over to our website at astronomydaily.io, where you'll find our continuously updating news feed with all the latest developments in space and astronomy. While you're there, you can catch up on all our previous episodes and sign up for our free daily newsletter to stay informed about everything happening in the cosmos. Want to connect with us on social media? You can find us as Astro Daily Pod on Facebook, X, YouTube, Tumblr, and TikTok. Until next time, keep looking up and stay curious about our amazing universe.